Hi students, hope all of you are doing well. Today I want to discuss an iterative method or iterative method, sometimes they will pronounce like that, of finding of roots of an equation. Okay, so we have seen lots of methods of finding roots of an equation, right? Newton-Raphson method, regular falsy method, secant method, okay, bisection method. Today I want to discuss a basic iterative method of finding the roots of an equation. Okay, so you can write it down, method of iteration or fixed point iteration method. Fine. So basically what will be given in the question is a function, right? A function fx equal to 0. This will be given in the question. So fx or some fu, something like that. Anything, any function. What you need to do, you need to calculate the value of x or the independent variable what they will keep. They can not necessarily they will all time they will write x. They might write some other variables also, right? U, m, like that way. Okay, so basically you need to find the root. What you need to do is they will give fx is equal to 0. What you need to do is you need to rewrite that equation in such a way such that in the left hand side only x will remain. That means in the left hand side of an equation only x will be present, and in the right hand side the rest of the term will, you can keep the rest of the terms in the right hand side. Fine. So let's see. So here it is. So fx will be 0, will be given, this will be given in the question. You need to rewrite such that x will be in the right hand side, x will be in the left hand side, beg your pardon, and other terms will be in the right hand side, which I have written as a new function phi x. Okay, then what you need to do is you need to calculate find the derivative of this phi x. Okay, and you need to check whether this phi dash x, the derivative, lies within this range or not. Phi dash x should be lie within -1 and 1. Remember one thing, or you can say in other words, is mod of phi dash x should be less than 1. Mod of phi dash x. Okay, so this is your basic condition. Then how can you find this mod x value? Phi dash x means you need to put some values of x, right, in the function of this phi dash x. Then you will be only getting a fixed value, and then you need to check whether that value is less than 1 or not. The mod value is less than 1 or not. Fine. So let's see an example, then it will be more clear to you. So this is a problem. 2x minus log base 10 x minus 7 is equal to 10. So this is equal to fx. This is basically here fx is equal to 0, right? So fx is this whole part, fx is this one. So what you need to do is the process remains the same. You need to first choose two values such that for one value the function is negative, for another value the function is positive. This is same like what we have done earlier. We need to choose two values. One, for this case it is minus 1.47. If we put x is equal to 3 here, you will get minus 1.47. So this is basically negative. And if I put x is equal to 4, then you will get 0.39. This is greater than equal, this is positive, right? Greater than 0. So that means my root lies between here, between these two values 3 and 4. So my root lies between 3 and 4. So this is your first thing you need to guess. Then rewrite this equation. Now this is a twist. This is the uniqueness of this method. You need to write this equation in such a way. So x will be in the left hand side. X will be in the left hand side. Other things will remain in the right hand side. See, I can move this 7 here. So minus 7 will be plus 7. Plus 7. Now I can move this one in the right hand side, so plus log 10x, so plus log 10x, and 2 is multiplied with x, and here it will be the whole thing will be divided by 2. And this is your basically your phi x. This whole thing is your phi x. That means x is equal to basically phi x. What you have done. Okay, then what I told you is you need to find the derivative value, right? And need to check whether the mod value of the derivative of phi x is less than 1 or not. Okay, so let's see. This is your phi dash x, right? So phi dash x is basically, if you take the derivative of this, it will be 1 by 2x log base will be e and 10. Base e means log e base basically ln, right? This is your phi dash x. Fine. Now what you need to do is, now if since the value is x, how can you make sure that this phi dash x is less than 1? How can you do that? You need to put some value of x, right? You need to put some value of x. So here we have seen that the root lies between 3 and 4. So what you need to do? Put 3 here and then put 4 here. Okay, so if I put x is equal to 3 here, what I will get is 1 by 6. This part will remain the same and you will get 0.07. And if I put 4, x is equal to 4, then I will get this one, 0.05. Right? So these two values you will get. Now what you need to do is see which one is maximum, this one or this one. So maximum of this one and this one, make sure you take the mod value. Okay, so what is the maximum value? Maximum value is 0.07 in this case, and it is less than 1. That means you can proceed with this method. The condition is satisfied and now you can proceed with this method. Fine. So this is your first step. You need to choose two values such that the function value is such that function value changes the sign. Then you need to rewrite the equation. Then you need to take the derivative of this phi dash x and put the value of x, your lower limit and upper limit here. Lower limit is 3, upper limit is 4. Check the sign. Then choose the maximum value of this two and then check whether it is less than 1 or not. So up till this I hope it is clear. Next step is to choose an initial value of x. What aim is to basically to find the value of x. Yes. So first choose the first value of x. Initial guess will be 3 because we have seen that it should lie between 3 and 4. So choose the lower limit. X0 is equal to 3. Fine. Then what you need to do is construct this table same like what we have done earlier. This is your iteration number or iteration number, whatever you pronounce. This is your x values and this is your phi x values. N means it is this n. Okay. So in the first step, see what is my x0? x0 is 3. Okay. So then how can you calculate phi x3? How can you calculate phi x3? See, put the value x is equal to 3 here. Put x is equal to 3 here. So 7 plus log 10 7 plus log 10 3 by 2. If you solve this, you will get 3.7. Okay, this is your phi x, right? This is your phi x. So phi is basically for the first of iteration 7 plus log base 10 3 by 2 and you will get 3.7. Now in the next step what you will do, whatever you got as phi x n in the last step, in the previous step, that will be your xn now. Okay, so this will be your xn now. Since we have written x is equal to phi xn, so I can write this one as this. But remember, this one is previous value, one is next value. This one will play its role as the new next value of x. Now my value is 3.7. So what you need to do is again find the value of phi x. Okay, so now my x value is 3.7, right? So 7 plus 10 log 10 is 3.7 by 2. So what you will get? 3.78. Fine. The next step, this phi x value will be your x. Same process. Then again you need to find this, you put this value here, again you need to calculate 5x, again you will get this one. Okay, similarly you need to construct. Then where to stop? They have written here, you need to cut it up to 4 decimal places. So see, in the fourth step, see the last 4 steps. 3, 4, 6. See, after decimal places, how many places they need to 4. So after decimal 4, 1, 2, 3, 4. Here 1, 2, 3, 4. 1, 2, 3, 4. Oh, 1, 2, 3, 4. All are same, right? 7.7892. 7892. 7892. 7892. Okay. Then you can ask me, sir, why haven't you stop it here only? You can stop it here, right? Here. In the fourth step, because in these 2 steps the decimal places, means up to 4 decimal places, the values are same. But I will recommend to do 2 or 3 more extra steps so that you will get more accurate result. This will give more accurate results, right? So even if this in this step we are getting same values almost, just proceed or perform 2 more operations, 2 or 3 more operations to get the final value. This is up to you, no problem. If you stop it here, no problem. Okay, the answer will remain the same. But see, if I do this, and if I just round this values, if I correct this, then see this value is greater than 8, greater than 5, right? So if you round it up, it will be 0.7893, and for this also, after 2, the digit is greater than 5, right? 7 is greater than 5. So if you round up it, so 0.7893. So you can write the equation 3.7893. But if I have stopped here, then it will be 3.7892. But see, if I proceed 2 or more steps, I can approximate these values. That means we have more closer to our goal. That means it will be more correct, I think. So I will recommend it to do 2 or 3 more extra steps. And in bisection method, I've told you how long you need to calculate the do the process. Okay, that means I have given equation for the value of n, right? N equals something like that. You can apply it here also, but that formula will not work here. This is a different process. Okay, so I told you, even if it is same, just proceed 2 or more steps, right? So this is your method. Very simple method. You need to rewrite the equation. The change is here. The difference from other method is the change is here. We are rewriting the equation such that x will be in the left hand side and other things will be in the right hand side. Then we are checking whether phi dash x is less than 1 or not. Then we are solving. Fine. This is the iterative process or iterative process. So this is your problem. So your answer is 3.7893. Okay. Now see another problem. So here the function is 3x minus cos x minus 1 is equal to 0. Okay. So I can write x as 1 plus cos x by 3. So this is your phi x. Now if I take the derivative, it is minus sin x by 3. Now sin x, we know sin x lies between the value of sin lies between minus 1 and 1. So if you take the mod of sin x, it is less than 1, right? So phi dash is less than 1. Okay, so you can do this method also. You can apply this method also here. And for in this case, if you solve, you will get this. That means your root will lie between 0 and 1. That means if you do follow the same process, you will see the root will be between 0 and 1, and you can apply this method since this phi dash x is less than 1. Last thing, and you can proceed in the same way. The last problem, see, here it is. x3 plus x minus 1 is equal to 0. Now you see, I can write this x in different way. So there are 3 possibilities. X equal to 1 plus x square plus 1, I can write in this way, or I can write in this way, or I can write in this way. So I am getting 3 phi x, right? So phi 1x, phi 2x, phi 3x. Now the question is, which one to choose and which one to choose between among this. Which one to choose? What you need to do is you need to calculate phi dash x, right? You need to calculate phi dash x, phi 1 dash x, phi 2 dash x, phi 3 dash x. Calculate this. Okay. Then check for the condition of phi x, mod phi x less than 1. Which one was good? See, here if you do, you will see the root lies between 0.5 and 0.8. So what you need to do, put 0.5 in phi 1x and see what is the value. Put 0.8 in phi 1x and see what is the value. Then see what is the maximum value of those two. What is the maximum value between these two values? Then you can judge whether it is greater than 1 or less than 1. Okay, if it is less than 1, you can proceed with this. If it is greater than 1, you can't. So you can't apply there. So you will see for this case, if you do it at home, for this case, for phi 1x, it will be less than 1. Your phi dash x will be less than 1, and for phi 3x, it will be less than 1. For this one, it will be greater than 1. So we can't take phi 2x. That means this point B, I can't write x in this way. Okay, I can't use. You can either do this or this, but for this case, if you choose this one, it will converge more rapidly. You can do this also, no problem, because for here also mod phi 3 dash x will be less than 1 if you do this. But if you choose this one, the steps will be less. It will converge very fast. Okay, so this case may arise that you can write x in different ways. Then what is the way out? We need to calculate the derivative and see whether between this range your mod phi dash x is less than 1 or not. Process is same. You can need to choose the maximum. Okay, and see whether it is less than 1. Okay. In this way, and then the process remains the same. Same process, nothing, no need to worry. Okay, so this is your method of iteration or fixed point iteration. Remember the condition they will ask in the as an MCQ question. What is the condition? Many times they will we have seen questions in the university. So mod phi x should be less than 1. This much you need to remember. And if any problem, if they give you any problem, you need to proceed. You need to solve in this way. Fine. So another thing, this is your what is method of iteration. While discussing the regular falsy method, I told you about secant method, right? What is the difference between the secant and regular falsy method? In regular falsy method, after in each step, we are calculating the function value at xn, fxn, right? We are checking the sign whether it is greater than 0 or less than 0. If it is greater than 0, the interval changes, and if it is less than 0, the interval changes in another way. That means your a and b will change depending on the sign of the previous value. Okay. But in secant method, you need not to check the sign. You need not to check the sign. What you can do is simply your b will be your a and your x, new value of x, that means previous value of x will be your b. And in this way you can construct the table and you can solve. So this is the difference in regular falsy method and secant method. So no need to check the sign of fxn. Okay, in each step, no need to check. Simply in the next step, that means you need to update your range by this way. Okay, this is already I have discussed in the regular falsy method video, right? So still I have given you the process. I have discussed the process once more. Okay, so these are the methods of solving or finding the roots of an equation. Okay, in the next class we will be solving, we will be seeing what are the methods of solving linear algebraic equations. Okay, so for the time being, stay safe. Thank you very much.